Hey guys, so in this video we are going to start questions on causal and non-causal systems. And if you haven't watched my video on causal and non-causal systems, then you should watch that. The link will be in the description below. So now in this video we are going to practice questions. So the question number 1 is, suppose we are given a function that is yt is equal to x of t minus x of t minus 1. So if you have watched my previous video, you know that this is the output and these two are the inputs. So now the question is, we have to find out whether the given equation or the given system is causal or non-causal. So first of all, let us take an example. Let us take t is equal to 0 in this case. So if we put t is equal to 0, we will get x of 0 minus x of 0 minus 1. In that case, we will get x of 0 minus x of minus 1. So this will give us the present input, and this will give us the past input. So what we can say is that the output, that is yt, is dependent on the present and the past value of the input. So in such a case, we know that the system is causal. So now let us do question number 2. Now suppose we have a function, say yt is equal to x of t plus 2x into 3 minus t. So now again we are going to check by putting t is equal to 0. We can put other values of t also, but we can initially start with t is equal to 0. Now we will write y of 0 is equal to x of 0 plus 2x 3 minus 0. So we will get x of 0 plus 2x of 3. So now here you will notice that the output, that is y of 0, is dependent on the present, that is the present, and over here we will get the future, because we have 3 over here, and we have 0 over here and we have 3 over here, so we can say that this is the future, because the output will depend on the next value of the input. So we can say that the output is dependent on the future values of the input. So in such a case, we know that whenever the output is dependent on the future, the system is non-causal. So now let us move on to question number 3. Now suppose we have a function, or we have a system equation, that is yt of is equal to x of 2 of t. So now let us put t is equal to 0. Doing that, you will get y of 0 is equal to x of 0. So now we will put t is equal to 1. Let us see another case. So over here we will get y of 1 is equal to x of 2. So over here we saw that we were getting the same value, as that is we were getting y of 0 and x of 0. So this was the present input, that is the output was dependent on the present input. And over here when we put t is equal to 1, we got y of 1 is equal to x of 2. So we can say that the output is dependent on the future value of the input. So you know that in this case, this system will also be non-causal. Now guys, let us move on to question number 4. Suppose we have a function, that is x of y of t is equal to x of t square. So now let us first of all put t is equal to 0. Now doing so, we will get y of 0 is equal to x of 0. And this is the present, as we know, as the output is dependent on the present value over here. Now in another case, we will put t is equal to 1. So now on putting t is equal to 1, we will get y of 1 is equal to x of 1. Now over here also we are again getting the present value. So now let us move on to another part. Say we put t is equal to 2. On doing that, you will get y of 2 is equal to x of 4. Now we will see that this is the future. That is, your output y of 2 is dependent on the future value of the input, that is x of 4. Now we can put, now we have got our answer by these these three cases also, but I will tell you another one. Suppose I put t is equal to minus 1. Say t is equal to minus 2. On doing so, you will get y of minus 2 is equal to x of minus 2 whole square, and on doing so you will get x of 4. So in this case also you will see that the past value of the output, say we can say that the previous value of the output is dependent on the future value of the input. Over here also we will see that this is the future. So we will say that this system is also non-causal, as our output is dependent on the future value of the inputs. Now guys, let us move on to the fifth question. That is question number 5. Suppose we have a function that is y of t is equal to t into x of t. So now let us put t is equal to 0. First case, that is you will get y of 0 is equal to 0 dot x of 0, and you will get 0 over here. And similarly, now let us put t is equal to 1. Now we will put y of 1 is equal to 1 dot x of 1. You will get x of 1 over here. And now let us put t is equal to 2. On doing so, you will get y of 2 is equal to 2 into x of 2. So now only the present values are coming at t is equal to negative if you put t is equal to negative. That is, suppose I say that t is equal to minus 1. Then you will get y of minus 1 is equal to minus 1 x of minus 1. So you will notice that we are only getting the present values. That is, for y of 0 we got 0, for y of 1 we got x of 1, for y of 2 we got x of 2, and for y of minus 1 we also got x of minus 1. We only have to look at the input, not the coefficients. So we are only getting the present values. So we know that if we only have the present values, then the system is causal. So now let us move on to another question, that is question number 6. Suppose we have a function that is y of t is equal to x of minus t. Now let us put t is equal to 0. Now on putting t is equal to 0, you will get y of 0 is equal to x of 0. So this is the present, as we all know that the output is dependent on the present value of the input. Now let us put t is equal to 1. On doing so, you will get y of 1 is equal to x of minus 1. So now this is the output is dependent on the past value of the input, as we are getting x of minus 1. Now similarly, if we put t is equal to 2, then we will get y of 2 is equal to x of minus 2. So this is also the past value, that is the output, that is y is dependent on the past value of the input. Now let us see another case in this question itself. Now let me put t is equal to minus 1. Suppose if you don't test for negative values of t, then if you see this, then you will write the answer as causal, which will be wrong. Because there is another case. Suppose if I put t is equal to minus 1, then I will get y of minus 1 is equal to x of 1. This is x. So here you will notice that this is the future. That is, the output is dependent on the future value of the input. So if you had written causal for this part only, then your answer would have been wrong. We had to see the cases where we will get future also. In some cases we might not, but in this cases we are getting a future value also. Let me give you another example. Suppose we took t is equal to minus 2, then we would have got y of minus 2 is equal to x of 2, which is also the future. So we will take all these values, that is from the top to the bottom, that is for positive 0 value of t, for positive values of t, and for negative values of t. And on doing that, you will get present, past, as well as future. So we know that whenever future is there, then the system is non-causal. So guys, this is it for this video. If you were able to understand this, please subscribe my channel and please hit the like button, and do subscribe the channel guys, as I can see that most of the viewers who are watching my video, they're watching it, they're liking it, but they're not subscribing the channel. So please do that. It helps me and motivates me to create more such videos and help you understand the concept, which took me a longer time to learn. So now guys, I have discussed 6 questions, and these are enough for you to ace your college exams if they are asking about causal and non-causal systems. We will be discussing non-causal and causal systems a little more detail in the next few videos, in which I will be telling you about different types of causal and non-causal systems, and we will also discuss the anti-causal part. That is, what are anti-causal systems. For now, this is it for this video guys. See you in the next one.